swords made of the legendary alloy known as Damascus steel were renowned in medieval times not only for their unique beauty, possessing wavy bands on their surfaces reminiscent of flowing water, but also for their incredible sharpness and toughness. The swirling patterns of dark and light stripes on ancient Damascus steel resulted from a combination of hard and soft layers with different shades caused by differing levels of carbon. These alternating layers gave the steel excellent strength. The hard layers resisted damage, while the soft layers reduced the overall brittleness of the alloy. Although the steel is named after Damascus in Syria, the metal was actually produced in India. The secret of how to forge this alloy was eventually lost, and metallurgists have debated for generations how it was made. Inspired by this ancient metal, researchers have now used lasers to create an even stronger alloy. The researchers created their steel in cycles by repeatedly spraying a powder made of iron, nickel and titanium onto a surface and then blasting it with an infrared laser, a kind of 3D printing technique known as laser additive manufacturing. After every fourth layer was produced, the molten alloy received a 2-minute respite in which it cooled rapidly before it was coated with a fresh sheet of powder and lit up with the laser. All this work took place in a chamber filled with argon, which as a noble gas would not chemically react with the metals. The cooling triggered grains of nickel titanium only nanometers, or billionths of a meter, wide to form within the steel. These particles hardened the steel by preventing any defects from moving around within the alloy. The cycles of heating and cooling produced a metal with alternating hard and soft layers much like Damascus steel. All in all, the new metal had a tensile strength of more than 1,300 megapascals and enough ductility to stretch up to an extra 10% of its length before breaking. In comparison, modern attempts to forge Damascus steels using ancient techniques only had a tensile strength of 1,100 megapascals and could elongate only 9.5% before breaking.